In Chapter 5, you worked with quadratic polynomials, and in Chapter 6, you're going to be working with several different types of polynomials. So I want you to be able to identify, add, subtract, and classify polynomials. So let's first just define what a monomial is. That's the smallest type of polynomial. It's a number or product of numbers and variables with whole number exponents. And it's the simplest type of polynomial. Now, when we say whole numbers, there are no negatives, no decimals, or fractions. A polynomial is a monomial, or it could be a sum or difference of monomials. And a term is each individual monomial in the polynomial. When we talk about the degree of a monomial, it's the sum of the exponents of the variables. When we talk about the degree of a polynomial, it's the degree of the term with the highest degree. Okay, let's talk about how to identify polynomials. A polynomial has no variables in the denominator. So if you have 1 over x, that is not a polynomial. And it's not a polynomial because x is in the denominator. You can have no variables in the exponent. So this one is not a polynomial because x is in the exponent. And you can have no variables under the root or radical sign. So here's an example of what that would look like. And no polynomials have absolute values of variables. So a variable inside of an absolute value sign. All variables have whole number exponents, real important. So whole numbers we defined earlier in the year would be 0, 1, 2, 3, and so on. Okay, so to determine if you have a polynomial, you just need to look at the variables and make sure they look like none of these here. All right, I'm going to give you some examples of polynomials and non-polynomials. We're going to look at them and decide, first of all, identify the ones that are polynomials and then decide why other ones are not. So here, if we're looking at the variable, we have a whole number exponent. Here we have a whole number exponent. Here we have a whole number exponent. Here we have a whole number exponent, and here we have a whole number exponent. None of the variables are in the denominator, they're not in the exponents, they're not under a root sign, and they're not inside an absolute value. So here are some examples that are not polynomials, and we're going to circle why they are not. This one has a variable in the exponent. This one has a variable in the denominator. This one has the variable underneath the square root sign. And this is kind of hard to see, but there's a decimal here, so it's not a whole number exponent. And so we'll circle this. And this one has a variable inside the absolute value sign. Now we're going to identify degrees of monomials and degrees of polynomials. So for a monomial, you just look at the individual term and you add the exponents. So here's my monomial. And one thing I want to make sure that you understand is that when a variable doesn't have a number on it, it's automatically 1. It is not 0 because anything to the 0 power would be 1, which would change the whole thing just to the number 1. So this is e to the first power. We're going to add the 2, 7, and the 1 to get 10. So that monomial would have a degree of 10. The next one, again, there wasn't a number, or we didn't see that number on the x variable, but it's assumed that it's 1. So we have 1 here, 8, and 7. So add those together, we get 16. Now a polynomial has either 1 or more terms. So what we're going to do is we're going to find the degree of each individual term, and then we will pick the highest degree. So here's our first one, and we already figured this one out. We have 7 and 2 is 9 and 1 is 10, and this one would be 15 and 16. So there are 2 monomials in this polynomial. We picked the one with the highest degree. This one has 10, this one has 16, so we're going to choose the degree 16 for this one. So always choose the highest after you figure the individual monomials of the polynomial. All right, now the next one we have This one is going to be 9 and 2 is 11, and this one would be 15, and this one would be 16. So again, 16 is the degree of the polynomial. It's the highest degree of the individual monomial inside the polynomial. Okay, a polynomial is in standard form, and when you write your polynomials, you're going to put them all in standard form. And you know it's in standard form when its terms are written in descending order by their degree. And that means that the degree of the first term of a polynomial in standard form indicates the degree because it's going to be the highest. It's listed first. So when you look at the first term in a polynomial in standard form, that's going to give you the degree of the polynomial. And the leading coefficient is going to be the coefficient of the first term. So the coefficient is the number in front of the variable or variables. Okay, here you have a polynomial that is in standard form. We have cubed, squared, first power, and then the constant. So the leading coefficient would be the 5 because it's the coefficient that's in the lead. And the degree of the polynomial, we don't have to look at any of these if we're in standard form because the highest degree when you're in standard form is listed first, and it's also the degree of the polynomial. So we have actually 4 terms, and that's going to help us name a polynomial. So another thing that you're going to be doing today is classifying polynomials. And there are 2 ways that you can classify polynomials, or 2 classifications for a polynomial. It can be classified by its degree and by its number of terms. So kind of think of it as having a first and last name, and you can take off that apostrophe there. Its first name indicates the degree of the polynomial, and its last name indicates the number of terms of a polynomial. So if I gave you, told you that you had a cubic binomial, then you should know that it has a degree of 3 and there are 2 terms. So here's a table that you can use when you're classifying polynomials today, but you will need to memorize it. A constant has a degree of 0, so that means it does not have any variables in it. So that's, and we'll just write no variables here. If you had a variable and you put a degree of 0 on it, that would just turn into 1. So no variables and a constant. Linear, we worked with a lot of linear polynomials earlier in the year, and they have a degree of 1. And if you would graph this, that would look like a line. We worked with quadratics in the last section, and quadratics have a degree of 2. So there is an example of a quadratic, and if you would graph that, it would look like a parabola. A cubic has a degree of 3, so the highest exponent on the individual term would be a 3. Quartic has a degree of 4, so here we have the highest degree. This is listed again in standard form, which you want all of your polynomials when you're finished to be listed in standard form. And then you have quintic, which is a degree of 5. Now, quartic, you can kind of think of quarters. There are 4 quarters in a dollar. And quintic, you can think of quintuplets. Quintuplets are when you have 5 babies born at one time. And quadratic you should know because we've talked about that. Cubic, you know that this would be x cubed. And we worked with linear before. If a polynomial has a degree of 6, so we just have specific names up to 5. If it has a degree of 6, you refer to it as a 6th degree polynomial. So the same is true for polynomials with degrees higher than 6. So you would have a 7th degree polynomial, 8th degree polynomial, and so on, depending on the exponent. Now, so that would be their first names for the polynomials. Now, the last name, you would classify the polynomial by the number of terms. So if you have 1 term, think of a prefix that means 1. That's a monomial. 2 terms, again, think of a prefix that means 2. That would be a binomial. And 3 terms would be a trinomial. And 4 or more terms, so we just have 3 specific classifications for polynomials, just 1, 2, and 3. If it's 4 or more terms, you would just say polynomial with however many terms. So in this case, it's 4 terms. So if we had 6 terms, we would say polynomial with 6 terms. Okay, now adding or subtracting polynomials, and you've already worked with this before. When you add polynomials, you just look at the degree and you add terms with like degrees. So these are not in standard form. This one is, but this one is not. So I'm just going to put this one is, just recopy this one and put this one in standard form. Just line them up under their like terms, and then I can just add down the columns. So I end up with 16x cubed minus 30x squared plus 6x minus 16. Now, when I subtract polynomials, always be careful when you're subtracting. Probably the best way to do this is take the opposite of everything that follows in the second polynomial, and then I'm going to line them up again. This one is not in standard form, so I'm going to put that in standard form. 5x cubed comes first, 6x squared is second, and then we have the plus 12. And I'm leaving a little space here because I can see that we have a linear term here, which we don't have here. So I'm leaving space for that. I'm taking the opposite of everything here, so it's negative 15x squared minus 3x, and then a plus 2. And the reason why I say take the opposite, because a lot of times students forget to subtract the second and third or fourth term. So when you take the opposite, then you can just add down the column. So here we have 5x cubed, and that's going to be minus 9x squared, minus 3x, and then plus 14.